Hello, right, this is lesson 3 and this is all to do with rounding and estimating. Now, a sort of real life problem where you're estimating or rounding numbers is if you go into the supermarket and you buy something that's $4.99, something that's $3.98 and something that's $3.94. What you do is you call that £5, yeah, call that £4 and call that £4, and then you just add the rounded numbers or the estimated numbers, which is 9, 10, 11, 12, 13 pounds, so that by the time you get to the checkout you know more or less how much it's going to be. So this is sort of what we're going to do now. Rounding is when you're rounding the numbers like this, rounding is done at the end. At the end of a calculation. Do not do it before you calculate. So you calculate for example, say you're calculating the volume of the town hall. You do some complicated calculations. You get right down to the end, and on your display on the calculator, you get all these numbers. 851. I don't know how big your calculator is, but that's too big, isn't it? So you're going to you could say that was 3 or 3.1 or 3 I don't know, 5, something like this. So you're rounding the numbers to make it shorter. Now there are rules when you're rounding, and there is 2 types of rounding. And the first rule that we're going to look is the rule of 5. Now this is the number that determines the rounding. So if it's 5 or more, you round up. If it's 4 or less, you round down. Round down. So how does this work? So say you've got 53 and you want that to the nearest 10. It's either going to be 50 or 60. Now the 53, 3 is less than 5, so you round down to 50. If you have 57 to the nearest 10, you'd go up to 60. And if you have something that's right in the middle that you could either go up or down, you use this rule. It's 5 or more, so you go up to 60. So let's have a look at this in more detail with rounding to decimal places. Now first of all, we've got to know what decimal places are. So 4.628, there's a decimal point, and this is our first decimal place. This number is our second decimal place, and this number 8 is our third decimal place. So that's where the decimal places are. So if we imagine we want to round this number to 2 decimal places, and it's always something that's often tacked on to the end of a question, it means we don't want to see any more decimal places in our answer than 2. So we look along this number and we find our second decimal place, which is there. Then you go to the right, and this number determines whether you're going to go up or go down. Now, because this is 5 or more, we will go up. So we go up in this one. And what we do is we add 1 back onto the 2 to make it a 3. So that rounded to 2 decimal places is 4.63. And afterwards, do that so that you can tell the person that you're marking your work that you have gone to the trouble of rounding that to 2 decimal places. So look at another one, yeah? So 4.723. So we'll do this to 2 decimal places again. And what we're going to do is look for our second decimal place, which is there. Go to the right, and this number determines what we're going to do. It's less than 5, so we can ignore it, and we can go down to 4.72, and we would just lose that, ignore it. Now you don't put a 0 in there unless it's very peculiar circumstances. You would just throw it away because it's a 0 after a decimal point, so you wouldn't normally put it. Now let's have a look at some other numbers, just rounding up and down to decimal places. So 6.925 and 6.98. Let's make that 6.88. Yeah, we don't want to get into the world of fantasy because you won't get numbers like that. So let's round this to 1 decimal place, and the same with this, 1 decimal place. So you look for the first decimal place here, which is the 9. You go to the right, and the 2 is less than 5, so you ignore all the numbers, including the 2 and everything that follows it. So that would come out to 6.9, 1 decimal place. This one, 688, first decimal place. Go to the 8. Oh, we add 1 back on. So we add a 1 back onto that, and that becomes 6.9 to 1 decimal place. Now I will do that awkward one. We're going to do 6.98. We're going to do this to 1 decimal place. So you go to the 1 decimal place, you look to the right, and we have to round up. So we add 1 onto the 9. Now this is awkward because it becomes 10. You can't have a 10. So the 10, the 1 carries over and adds on to the 6. That becomes 7, 0. Now this is the only time that you will write a 0 after the decimal point when you're rounding to decimal places, because that is the first decimal place. So you have to put that in. That's the only time it gets awkward, is when you have a 9 that you're adding 1 onto. So you have to leave the 0 there. Right, the other way of rounding that we looked at was significant figures. A little bit different, but more or less the same. Now, every number after any zeros is significant. For example, if you've got £304, the 0 is very significant. Otherwise you would just end up with 34 if you think, well, that doesn't count. So it is significant. Any zeros. So let's have a look. Now we said that every number after any zero. So if we have a whole number, 492, there are no zeros there, so every one is significant. So that one is the first significant figure. There's the second. Oh, I could write. Let's write SF. Make it clearer. Otherwise, we've got too many letters there. Second significant figure, and this one is the third significant figure. So if we want to round this number to say 2 significant figures, we'd look at the second significant figure there, and we go to the right, just as we did with the decimals. That's less than 5, so we can ignore it. So we end up with 49, but in this case we have to put a 0 in there, otherwise the size of the number changes. So 492, to two significant figures comes out at 490. Now we mentioned about zeros. Obviously you don't get any zeros at the beginning of a whole number, but you do when you're using decimal numbers. So if we've got 0.0048 and we want to round this to two significant figures. Now remember, anything before the numbers that are zeros are not significant. So that doesn't count, that doesn't count, that doesn't count. There's our first, there's our second, there's our third. So we go to the second significant figure, look to the right, is it 5 or more? Yes, so we'll add 1 back onto that 8 to give 0, 0, 49 to two significant figures. If we had 0.00444 and we want this to two significant figures, we'd go nope, 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 1, 2, 3. There's our second significant figure. Look to the right, and it's only a 4, so we can ignore it. So we end up with 0, 0, 44, and this time you don't have to put the 0 at the end. There's two significant figures. There's one, there's one. Now, remember I mentioned that £304, 300, and I said that the 0 was significant in that value. Well, the second part of this is any 0, I'll call it in the middle, is a significant figure. So let's have a look at this 304. Let's round this to two significant figures. Now there are no zeros at the beginning, so that's taken care of. This is the first. Now the 0, because it's in the middle, becomes a second significant figure. We're going to round to two significant figures, so we go to the 0, we look at the next one down, and that is less than 5, so we ignore it. So this comes out at 300 to significant figures. So the 0 counts when it's in the middle. So 0.08080. 8, I'll put an 8. Let's do this to two significant figures. So doesn't count, doesn't count. 1, the 0, all the zeros count from now on. So there's our second significant figure, the 0. We look to the right, which is an 8. It's bigger than 4, was 5 or more, so we add 1 on. So that becomes a 180.0 to two significant figures. We're going to do the same number, and this time we'll do to three significant figures, and doesn't count, doesn't count. 1, 2, 3, 4, 5. So three significant, there's the third significant figure. Go next door. Is it more than 4? No, just forget it. So see nothing after that third significant figure, and that's significant figures. Now this is always done at the end of a calculation, but estimating, which you will see at the wording in the question, has to be done at the beginning. And this is in case you get an awkward numbers that you can't do, you've got no calculator, and you just want to get an idea of what it might be, as we did with the supermarket example. So we're going to do something really complicated now to show you how estimating works. And we're going to do that plus that, and we're going to divide the whole lot by 56.2 times 3.2. Now, estimate. We've got to make the numbers nice and easy. So this one, 127.8, is a bit like the rounding rules, but not always. Well, we'll call that 130. And then we'll add, what can we add on there? Make it easy. Don't go up to 42. Just go to 40. Yeah, that easy as that. And what's on the bottom? 56. So we could round that right all the way up to 60, and then we can call that 3. So 130 plus 40 is 170. 60 times 3 is 180. Now we've got 170 divided by 180. Remember, we're just estimating, yeah? So we could say that's about, and that's that funny little wavy equals sign, it's about 1, isn't it? It's about 1. So you've got to make a whole number when you estimate. So let's do 3.9 times 5.2. 1.1 plus 2.9. Right, so 3.9, I'm going to make that 4, and I'm going to make that one 5, call that 1, and call that 3. So I get 4 5s are 20 divided by 4, which equals 5. So you can see how you estimate. Bit awkward that first one where it didn't come out exactly as right number as a whole number, but it's okay. Estimate. So best to look at the bottom figure first and see what that comes out as. See, we've got 1 plus 3. We made it 4. So we want something on the top that we can easily divide by 4. That's the way to do it, upside down sort of thing. Right, the next bit we looked at was error bounds. Now, this was quite tricky, this one. Now, in the question, you will always have this word, nearest. To the nearest something. Now, an example. We cut a piece of pipe there, lovely piece of pipe, and that is 100 centimeters long. So in the question, you'll say you've got a length of pipe 100 meters to the nearest 10 meters. Right? Now, to the nearest 10 meters gives us our tolerance. Now, 10 meters is the spread of the tolerance. Now, spread of the tolerance. So, this is how we do it. You take this number and half it, yeah? Or divide by 2, same thing, half it, which gives you 5 meters. Whatever that is, you half it to give you 5. And you go 5 meters up and 5 meters down on the length. This is 5 longer and 5 shorter. So if we go down, we would get a length of pipe that was 95 centimeters, because it's 100 take away the 5. I'll do that. 100 take away the 5. Then we're going to go up, so we add on the 5. So 105. So this means that you've cut a length of pipe and it's going to be between 95 and 105. So there to there is our 10 meters, and that's where we get the nearest 10 meters from. It's not 10 meters longer and 10 meters shorter, otherwise that will be 20 meters tolerance. It's a tolerance. So it can be 10 between the shortest and the longest. So it's half of that up and half of that down. Now, the shortest is called the lower bound. Yeah, the LB. The longest is called the upper bound. Can't call it longer and shorter because this could be weights. The upper bound. So that's how you work out an error bound question. Now, let's do another one. So we've got a sack of potatoes. They weigh 50 kilograms to the nearest 5 kilograms. Work out the lower bound and the upper bound. Right, you take this number and you half it, which is 2.5 kilos. Then we go 2.5 up and 2.5 down. So the upper bound is going to be our 50 kilo bag plus 2.5, which equals 52.5 kilograms. And the lower bound is going to be the 50 minus 2.5, which is 47.5 kilograms. Okay, so that's upper and lower bounds. You may have to work out the upper bound of one item and the lower bound of two and compare. Or you may have to write them in, I always forget what this is, bounds always given in, hang on a second, I'll work out, I'll come work out what that is in a minute. Right, now, when we, the error interval, yeah, I've got it at last, yeah, error interval. And this is a way of writing the weight and the upper and lower bound all in one little sort of line, one little algebra type thing, one mathematical line to represent what we're doing. So first of all, we've got to know these signs. A sign like this is usually called a greater than. Yeah, so we can have an example that 5 is greater than 4. Yeah, now that's reading it from left to right. If we read it from right to left, it would be less than. 4 is less than 5, so we can go backwards and forwards, and this sign can also go backwards and forwards as well. So if we had the sign that way round, and we'd have to have 4 that side, 5 that side, and that means that that sign round there going that way would be less than if we read it from left to right. 4 is less than 5. If we read it from right to left, 5 is greater than 4. So it points down to the small value and opens up to the big value. So we've got a greater than or a less than sign. So there's the greater than, there's the less than sign. But they are reversible. Now, if we have x is less than 3, all the possible values of x, and we'll just do whole numbers, it's got to be less than 3, so it could be 2, 1, 0, -1, and so on forever. If we have x is greater than 3, then the possible values of x is bigger than 3, so it could be 4, 5, 6, and 7, and so on. Now, there is another sign here, or rather a more complicated version of the same thing. Now, it's this. It's mostly written that way, yeah? And this means less than or equal to. So let's put that into action, and we'll have x and 3. So this means that x could be equal to 3, so the values of x could be 3, or it could be less than. So it could be 3, 2, 1, 0, and -1, etc. So you see the difference between the less than or equals to is just that it includes the value you can see on the other side, whereas the less than only, it started at 2, this one started at 3. We can reverse this sign by having a more than, which the values of x could be equal to 3 or more than 3, and so on and so forth. Now we've got to use these signs in order to write our error bounds, error interval. So let's go back to our potatoes that weigh 50 kilograms, and this time we go to the nearest 10 kilos. So we're going to write the error interval. Now in order to do this, you must find the lower bound and upper bound first. Okay, so let's do that bit. So here's the nearest 10. So we take 10 and we divide that by 2, don't we? Because we're halving it, equals 5. So there's our 5 kilograms. So we go 5 up and 5 down. And we start with our 50. So our lower bound is 50 minus 5, which equals 45 kilograms. And our upper bound is 50 plus 5, which equals 55 kilograms. So we've got our lower and upper number, and now we've got our original weight was 50, or potential weight was 50, and we're going to write the error interval. So what we do is we put the weight of the potatoes in there, and we've got the lower bound is that side and the upper bound is that side. So the weight of the potatoes are somewhere in between 45 and 55. We don't know, but that's the minimum it could be, and that's the maximum it could be. Now we've got to put our rounding head on to find out what symbols or what signs we used for this. Now, if you took the number 45 and rounded it to try and make 50, you would round up. So that means that 45 is either equal to the weight of the potatoes or less than the weight of the potatoes. If I read it from the middle out, it might make more sense. The weight of the potatoes could be more than 45, or it could be equal to 45, because that's the minimum. Is 45 rounds up to 50. Now we're a bit stuck here because 55 rounds up to 60, so it cannot be 55. It must be less than 55. So this way the weight of the potatoes is less than 55, because anything less than 55 rounds down to 50. Anything that is equal to 45 and above rounds up to 50. And these signs are always the same. A question you may get on this is, what's the error interval of the potatoes, as it were? And you'll be given 4 of these to choose from, with all the signs backwards, inside out, wrong way round, that sort of thing. And you have to tick which one you think is right. You'll get the numbers, you'll get the weight in the middle, but the only difference between the 4 options will be the signs to be pointing in different ways. So the signs always go round that way. And that, oh no, there's a little bit more I've got to do, yeah? A little bit more that we did. It was estimate Oh, it turns out to be a long lesson. Estimate square roots to one decimal place. Yeah, because it's only an estimate, yeah. So you've got to know that 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, yeah, because it's 3 times 3. 4 squared equals 16. You must know these off by heart. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared, 9 squared, 10 squared. That's as far as I'm going to go, yeah? 64, 81, and 100. Oh, go on, I've got a bit of room. Yeah, 1, 2, 1, 1, 4, 4. Know that. And know that the square root of 1 equals 1, the square root of 4 equals 2, the square root of 9, 3, square root, square root, square root, square root, root, square, 144, 100, 81, 64, 49, 36, 25, and 16 equals 4 equals 5 equals 6 equals 7 equals 8 equals 9 equals 10. I don't know what happened to by 121. Yeah, so you've got to know all the squares and all the square roots. And what it is, the square of a number is the number times itself. So for example, the 4. Yeah, 4 squared is 4 times 4, which equals 16. So the square root of 16 is a number times itself that equals 16, which is 4, because 4 times 4 is 16. Now, we will have to estimate square roots. If they said to you, what's the square root of 25? You just go 5, that's easy. But they might say, what's the square root of 18? And you're going to go, oh, don't know. But you do know the ones that are either side, because the square root of 16 equals 4, and the square root of 25 equals 5. So your answer is in between 4 and 5. So it's going to be 4 point something, yeah? Now, what you can do here, you go 16, and you make a line that goes all the way up to 25. So I'm going to do 17, 18, 19, 20, 21. You won't get numbers too big for this. 23, 24, and 25. So, and you've got to imagine that this is sort of 16.0 to 25.0. So that would be 16.5 in the middle, 16.1, 2, 3, 4, 6, 7, 8, 9. So we've made the difference between the two squares that we know into like the decimal place. So 18 is here, and the nearest one maybe is this one, 3. So the answer there is going to be 4.3 to 1 decimal place. That's how you do that, yeah? The square root of 115 is in between these two, and it's closer to that than it is that. This is 21 and 15, so I will call it 10.7, yeah? To 1 decimal place. That's how you do that. Okay, end of lesson 3. See you in the next one.